in this video we will see how connecting the same piece of object in different ways lead to different resistances, because we already know that resistance is equal to resistivity into length by area. Here they have given a solid block, a brick kind, a cuboidal block, and what is the resistance across A and B points and resistance across C and D points? What is RAB? Here suppose if the length of the block is L, breadth is B, and the height or thickness is H, then in this case what is RAB? So I'll just brought a look-alike. It is our length and this is our breadth. This is our breadth. It is like this. This is the length, this is the breadth, and this is the thickness. The first one is, what is RAB? RAB means you are connecting the battery across these 2 points, like positive here and negative here. So you are connecting the battery like this. This is what the meaning of this. Then in such case, what is AB? Then when you connect it like this, the length of the path, the current travel is this. So that is L only. And when you connect like this, perpendicular to the flow of current is this area of cross section. And we know that already this is B and this is H. So this area of cross section is BH. Then when you write RAB is equal to rho into L by A. L is the length, A is the area of cross section. Here L is L only, because when you connect like this, the current will flow through this. The length of the conductor is L. Area of cross section is this surface. This surface means B into H. So this area can be written as B into H, because this cross section is rectangular cross section. In the previous video we have seen a circular cross section. The area was pi r square. Now it is a rectangular cross section. So B into H. But when you connect across CD, that means if you connect like this, that means you have to connect a battery here like this. So now you have to remove this. You have to remove this actually. When you remove, when the wire is connected as shown this way across CD means this way you are connecting. That means you can say that this way you are connecting. So we know that already this is H. So when you connect across this battery, the length of the path the current travels is only H, and this area of cross section is, this is L and this is B, LB. So when you write resistance across CD can be written as rho into L by A, where L is the length of the conductor. Length of the conductor in this case, that means this is a positive, then the current comes this way and immediately crosses this point. So this H is the length of the conductor by area of cross section is across this. This is the area of cross section. I said no. So when you connect like this, perpendicular to the flow of current, this is the area of cross section. So it is L and this is B, L into B. So L into B. And the third one is, suppose this way if these two are connected. First we have said the wires are connected like this, the power is connected like this, and then connected like this. And then what if they are connected like this? Here is a positive terminal and here is a negative terminal. Then accordingly we can take it like this. Then in this way the current goes through a distance B, and across perpendicular to the flow of current, this area of cross section is there. This area of cross section is L into H. So R, maybe you can call it EF. REF is battery is connected between these two faces. Then that is equal to rho into L by A, and length of the conductor in this case is, when you connect this way, it is L is the length. When you connect this way, H is the length. When you connect this way, when you take it, the length is B. So it is B by area of cross section is L into H. and so on. So you know that in this way length is more, area of cross section is less, then the resistance will be more. In this case length is very less but area of cross section is more, and this resistance will be very high and this one will be moderate. But you can also, this also depends on the values of L, B and H. If they say L, B is half the L, H is 1/4 of the L, we can find the, we can substitute the corresponding values, we can compare RAB, RCD and REF. That way we can compare. That is not a big deal. So you will be able to do it, and in the subsequent videos we will take the tool of integration to find out the resistance.